Okay, so we've talked about some angles, we've talked about polygons. Let's talk a little bit more about something about polygons, the diagonals. Now, what are diagonals? Diagonals are just segments drawn from or connecting the vertices of a polygon. Now, a triangle doesn't have any of these. There's no way to connect this to anything else. That's a side. That's a side. I can't connect to it any other way. So triangles have no diagonals. But here we got a pentagon. I can see there's a diagonal. There's another diagonal. And I can draw a diagonal here. I'm going to draw a diagonal here. And I can draw a diagonal here. There's a lot of diagonals. In fact, it begs the question, how many diagonals are in a polygon? Well, let's start with the pentagon. It's pretty easy. We just said I've got one here. There's two. There's three. Four. Let's see, I connected there, so that's 5. And I get, oh, looks like it's only 5. Huh. 5 sides, 5 diagonals. Wonder if that works for a hexagon. 6 sides. I wonder if we get 6 diagonals. Let's find out. So there's 1, 2, 3. Okay. Can't go here. That's already connected. 4, 5, 6. Well, obviously I need more. Already went that way. 7, 8 over here, connected in those directions. Oh, there it is, 9, and that's all connected. So we've got 9. What about a decagon? 10 sides. Looking for a pattern. So let's start here. 1, 2, 3, 4, 5, 6, 7. That's all those. Now I'll go 1, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh my God, this is too many. Somebody stop me. What we need is a formula. So let's think about what we did here. Let's start with our simple pentagon. From this corner, I didn't connect to here or to there. So for every corner, I didn't connect to the one that exists and the ones on either side. So let's say I had n sides. I'm not connecting to 1, 2, 3 of those. Okay. And I did that for every one of these. So this one, all of them but 3. This one, all of them but 3. This one, all of them but 3. So I do that n times. But if I do it for here and for here, I did it twice. So I'm going to divide by 2. And this is a formula. This will give me the number of diagonals in a polygon. It's a lot easier than doing this a whole lot. So if we test that, our 5, so pentagon, if I test that, I've got 5 minus 3 over 2. Well, that's 5 times 2 over 2, which is 5. Well, that worked. Let's test it for 9. So for my nonagon, I've got 9 minus 3 over 2, which is 9. 9 minus 3 is 6. And that's going to give me, wait a minute. 9 minus 3 is 6. That's going to give me more than 9. Or did I miss some? Oh, because it's not a 9-sided. Sorry. Not a 9-sided. It's a hexagon. My bad. Which has 6 sides. I was thinking ahead. I saw the 9 here and got messed up. So it's 6. 6 minus 3 over 2. And 6 minus 3 is 3 over 2. That's 18 over 2, which gives me my 9 diagonals. So let's bring that back to my 10-sided. So 10 minus 3 over 2. So that's 10 times 7 over 2, 35 diagonals. Now, that's not too bad. I could have counted 35, but I don't want to go too much higher. So here's your job. Fill out a chart to see how big it gets with so many more sides and how many diagonals we can get. Last lesson, that's it. We'll come back on Monday. We'll go over this kind of stuff, and we'll start reviewing for a test. Sounds good. Have a good weekend.